All right, we're back, and in this one, we're going to be talking about modulus. This is something brand new coming in at us hot. In addition to the four basic arithmetic operators, right, we get addition, subtraction, multiplication, and division. Most modern day programming languages include a fifth operator, this percent sign. This percent sign is the modulus operator. When used, mod yields the remainder when one number is divided by another. Okay. I'm going to say this a few times. Modulus is division. Modulus is division. This is division. Modulus, the mod operator, this is division. In fact, this little percent sign, it looks kind of awkward, right? But what I finally come to realize is there's a division bar in here. That's why we're using it, right? Division, division. The only difference is division gives you the quotient, mod gives you the remainder. We're going to do the division operation. All of the division stuff applies. But the answer is not the quotient. The answer is the remainder. Let's take a look. 7 mod 2. Well, 2 goes into 7 3 times. Okay, so if this was division, our answer here would be 3. However, 2 goes into 7 3 times with a remainder of 1. That's what mod is doing. Right? 5 goes into 17 3 times with a remainder of 2. 3 goes into 6 evenly, so there's no remainder. So let's take a look at some expressions here. Right? 11 mod 3. I want you kind of maybe mentally or maybe even physically write this down. What do you think the answer is here? 100 mod 15. 20 mod 4. This one gets a little bit interesting. I have to check these every single time. 4 mod 10. And then 7 mod 0. What do you think our answer is here? Keep in mind, all it's doing is division, right? 3 goes into 11 3 times with a remainder of 2. 15 will go into 100 however many times with a remainder of 10. 4 goes into 20 evenly, so remainder is 0. This one's interesting, right? How many times does 10 go into 4? Well, 0 times with a remainder of 4. Let's make this canvas a little bit bigger here. I'll grab a brush. Right, what are we doing? We're going to increase our size for a moment. But I want to divide 4 into 10. No, other way around. I want to divide 10 into 4. How many times does 10 go into 4? Well, 0 times. Right? 0 times 10 is going to be 0. Our remainder is 4. So mod is division. But instead of being interested in the quotient, what we're interested in here is the remainder. Okay? Now this one should be no surprise. This is division. If I try to do division, right, divide by 0, that's an arithmetic exception. And this happens in Java. If you try to do this in Java, you're going to get an arithmetic exception. Syntactically, this is perfectly fine. I'm just dividing one integer by another. There's nothing wrong with that. But at runtime, when you actually execute the program, you would get this exception. Okay? Because this is division, this carries the same precedence as division, which means we need to update our mnemonic here. Our PEMDAS, or please excuse my dear Aunt Sally, I got to fit in another M in there. It's now my messy Aunt Sally. I know why we're excusing her. She's disgusting. Okay, so we're adding another M to our PEMDAS. It's PEMDAS now. In Java, we're going to tack on that modulus operator. Again, we see that little division bar. That's why they end up using the percent sign. Okay. There are some practice problems on Canvas if you want to practice the modulus expressions, right? These they start like chaining things together. You start getting expressions with like multiple arithmetic operators, and it's kind of a combination of things: addition, multiplication, along with mod. So if you want to practice these, feel free to do so. Not for a grade, but something you can do. So let's kind of take mod and focus in on a programming world. Why does this thing even exist? In programming, modulus has several niche uses that would otherwise be impossible without the existence of modulus. Okay, here I got x, that's some integer. I got y, that's some integer. And here inside of my if statement, I'm saying if x mod y is equal to 0. What am I effectively doing here? What is true about this? Right? If this is true, what does that mean? Well, if this is true, this means that y evenly divides x. This means that y is a divisor of x. Okay, we're going to see that again next unit. Maybe something that hits a little bit closer to home, maybe something a little bit easier to understand, and you're just like, oh, okay. Take a look at this. X mod 2. If that is equal to 0, what does that mean? Okay, well, based on our previous slide, it means that 2 is a divisor of x, but hopefully you see a connection here. If this is true, that means x is an even number. That's interesting. Now keep in mind, x could be anything, right? It could be user input. It's a variable. Okay, how do I check to see if it's an odd number? Well, here's one way. If x mod 2 does not equal 0, what does that mean? It means x is an odd number. So those probably get used a good bit, right? This is one way that I do, like, we're going to learn loops next unit. And this is one way to do every other type of thing. Like, this time I'm going to do this. Okay, next time I'm going to do that. And so this gets used actually a good bit. What we're going to do now is do division with remainder, right? We've been experiencing division in Java where the remainder basically is discarded, right? It gets truncated. We do division, we get the quotient, and we don't care about the remainder. However, when learning division, the result is often expressed along with the remainder. For example, 9 divided by 2 would produce 4 with a remainder of 1. And so what I want to do is write a program division that asks the user for 2 operands, then prints the answer along with the remainder. Order of the operands does not matter. Division should always divide the larger number by the smaller number. That's a little interesting. So here is an example. Please enter the first number. The user says 2. Please enter the second number. The user said 9. 9 divided by 2 is 4 with a remainder of 1. So this is a sample output of what I want the program to look like. If you feel like you know what you're doing, here's probably a good spot to pause and try it on your own, but I'm going to go straight into it. I got IntelliJ already up. I'm going to make a new project by going to File, New Project. I personally need to switch folders. So I'm going to do that. The name of this project is Division. D-I-V-I-S-I-O-N. I'm going to right click on my SRC, do a new Java class. I'm just calling that one Division. I'm going to plug in a main method with PSVM. And we need to implement scanner. I'm going to jump straight to step 2 because I've been showing you that you can just start typing and IntelliJ will IntelliSense. We can hit enter on that first option and it's going to not only complete the word scanner, but it's going to import it, right? It did step 1 for us. Finishing out step 2, I'm going to create this scanner called input that reads from system.in, the keyboard. Okay, why don't we prompt the user? I should tell him what this program does. This program preforms division on 2 integers and displays let's use maybe a separate SOP. The quotient, quotient along with the remainder. IntelliJ seems to like it. I'm going to assume that's correct. Okay, let's prompt the user. Let's ask for, please enter the first number. They've been prompted. I'm going to do step 4 of implementing scanner, which is actually getting that number. So why don't we create int, I don't know, 1, maybe x, I guess that makes sense. Int x is going to be equal to our input, that's our scanner, dot. In this case, I'm getting integers. So we'll do next in. Okay, let's ask them for the second number. please enter the second number. We'll save that into y. It's going to be input.nextInt. Okay, so we've told them what the program does so that we can simply ask for numbers, right? The only reason I do this is so that I can make this a little bit easier, a little bit cleaner. Right? Explaining to them what these numbers are before I just kind of get them out of the blue. All right, so one thing of note is that the order doesn't matter. We always do what the larger of the two is divided by whatever the minimum of the two is. I need to figure those things out. Okay, we know if statements, and we can do it that way. I'm immediately going to wrap back in the math class, right? We actually know an easier way to figure out the max and min. What I'm going to do is create kind of placeholder values, right? Placeholder variables. I have this integer max, and what I want it to be is the maximum of x and y. You could then go into if statements if you want to go that approach, but we actually know math.max. Math.max, which works with two integers. In this case, my integers are x and y. So it doesn't matter whatever the larger of the two is. I'm going to save it into max. And so what I want is for my program to work with max. I also need to know what my minimum is, right? So I'm going to create a minimum, and we'll do math.min on x and y. Okay, so I'm getting two values from the user. They could do it in either order, and I'm going to basically sort it so that they're in these variables, max and min, and so I'm going to work with max and min for the rest of the program. So I've got the user input. I've already sorted it out. I'm ready to do this math here, right? I want to say max along with, so this is my annotation. This is the output that is being displayed to the user, divided by min. So what I'm actually doing is saying like 9 divided by 2. I've produced this portion. Let's tack on our equal sign. Okay, so I'm up through this. So right here, this number, this 4, that's produced by actually carrying out the division and letting the truncation happen. So we could do that right here. You could also make some variables in advance and save those values in. So I want to do max divided by min. Right? Notice no quotes around this. This is the literal math. I want this math to happen. Okay? If it helps you out, put in some parentheses, right? This way you know for a fact that the precedence is going to happen here. Now, this addition, what we're doing is concatenating strings. We're piecing together strings up through here. But it's still addition, meaning it's going to have a lower level of precedence than our division. So these parentheses aren't necessary. But if this was addition, it would be, right? We would be just doing everything from left to right, and things could get a little bit messy from there. But because this is division, you don't have to have these parentheses. If it helps you kind of understand what's going on here, use them. Okay, so we're going to do the division there. That's going to produce my 4. I now need the rest of this. I need a space, an R, and a period. That is literal string text that I want to appear, so a space, an R, and a period. Right? We're going back to concatenation after the math happens. And the final thing I want is this 1. We got that by doing modulus. We did the division, but instead of the quotient, we got the remainder. So I'm going to plug that in here. We'll take our maximum value, we'll mod it by our minimum value, and that should produce that. Let's try this out. I'm going to right click in free space, tell it to run. Okay, we'll use our test case. It says this program performs division on 2 integers and displays the quotient along with the remainder. Please enter the first number. I'm going to do just like our example where we got a 2 and a 9. And there it is, right? 2 was actually the smaller of the 2 numbers. And so here we figured out what is the maximum. It was 9. So that gets saved into max. We figure out what is the minimum. That was 2, so it gets saved into min. And that kind of adjusts our display, right? So if I run this again, do the exact same numbers, but in a different order, I'm going to get the same result. 9 and 2, doesn't matter, we end up with that. Let's try some different numbers. How about 7 and 11? Right, we'll figure out that 11 is the maximum, so that when we get down here, 7 goes into 11 one time with a remainder of 4. Okay, so that's modulus. I'll see you in the next one.